In daily life, minor wounds are common. When they happen to healthy people, these injuries are quickly repaired. But for those suffering from diabetes, minor wounds can become chronic, remain open for a month or more, and possibly lead to amputation. This contrast has afforded scientists a unique opportunity to study the biological processes that take place when the body attempts to heal. Previous work investigated the production of new blood vessels from pre-existing vessels, the process known as angiogenesis. Another way of making blood vessels is vasculogenesis, the process of making blood vessels de novo. Vasculogenesis happens during fetal development and during some types of tissue repair. It's been widely thought that the basic steps of vasculogenesis involve stem or precursor cells making endothelial cells, which in turn make blood vessels. But new work by a team led by Professor Chandan Sen, reported in Nature Communication in March 2023, identifies the vasculogenic fibroblast cell as an independent driver of vasculogenesis. The skin, which is made up of the dermis and epidermis, also contains appendages such as hair follicles that provide a niche environment, hosting multiple cell populations displaying high levels of plasticity. When healthy people suffer minor wounds, the healing process moves quickly. Various cell types act in a coordinated manner, with fibroblasts playing a key role. It is well known that they are responsible for the manufacturing of the extracellular matrix and related processes. This work discovers that a subset population of fibroblasts, the vasculogenic fibroblast, responds to injury as a signal. In response to injury, these physiological cells start to acquire some of the key vascular characteristics of endothelial cells, while at the same time partly shedding their fibroblast characteristics. Thus, can start forming functional blood vessels within days to weeks, achieving blood flow to the injured tissue. Vasculogenic fibroblasts play a key role in rescuing the ischemic limb. Unfortunately, for those suffering from diabetes, the natural abundance of vasculogenic fibroblasts is low. Hence, their ability to make functional blood vessels is compromised. But the good news is that this can be reversed. Vasculogenic tissue can be reprogrammed using tissue nanotransfection technology, or TNT, a technology that enables tissue reprogramming in the live body. In this case of vasculogenic TNT, a microRNA 200B inhibitor is delivered to the tissue safely and quickly in under 1 second. It results in an increase in vasculogenic fibroblasts. Once a critical threshold is reached, these cells form new blood vessels, improving blood flow and closure of the diabetic wound. Forming and arresting new blood vessels is critical to the management of a wide range of ischemic and tumor-related diseases. This work discovers the vasculogenic fibroblast in wound patients and mice and provides a novel target for managing a wide range of disorders, including tumor regression, wound healing, and critical limb ischemia.